Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the paper 2 from 2022 time zone 1. All right, first one, number 1. Boris recorded the number of daylight hours on the first day of each month in a northern hemisphere town. Data was plotted onto a scatter diagram. Plots were joined by a smooth curve with minimum 0.08 right here and maximum 0.616 right here, as shown in the following diagram. Let the curve be in the diagram be y equals f of t, where t is time measured in months, since Boris first recorded these values. Boris thinks that f of t might be modeled by a quadratic function. A, write down one reason why a quadratic function would not be a good model for the number of hours of daylight per day across a number of years. A couple of things I can think of actually would be really the daylight cycle repeats every year, so it would be more of a sinusoidal would be a much better choice. And also, if this was truly a quadratic, it would go down like this and we'd end up having negative daylight, which of course would not make sense. So either one of those would be good. I would just write down one because they asked for one. If you feel confident with your one, stick with that one. Okay, so put those on there. Again, I probably feel more comfortable with this first one, quadratic. You'd end up with negative daylight. That doesn't make much sense there. So B, after this, Paula thinks that a better model is f of t equals a cosine bt plus d, where t is greater than or equal to 0 for specific values of a, b, and d. So for Paula's model, use the diagram to write down the amplitude and the period and the equation of the principal axis. So B part I, amplitude, if you'll remember, is how far up and down it's going to go, right? So our amplitude truly is half the distance from the bottom to the top, or basically from the middle to the top, or from the bottom to the middle. So probably the easiest way to figure that out, especially since they gave us a couple data points here, would be the lowest is 8 and the highest is 16. So if we do 16 minus 8, we get, excuse me, 8. And that's the distance from top to bottom. We want only half of that, so officially we're going to divide by 2, so we should end up with 4. So our amplitude is going to be 4, okay? And then the period, part II, period is how long it takes to repeat. So daylight hours, it's going to take a year for everything to repeat, so I would do 12 months. So that would be the period. We wouldn't actually put the months on there. It would just be 12. We wouldn't have to worry about that part. And then the third part, the equation of the principal axis. So the equation of the principal axis is right down the middle. It's pretty apparent that it's 12. If you want to show the math for that, that would be, we want to find the middle between 8 and 16. So we would do 16 plus 8. The average of these two, divide by 2, gives us 12. So our it is going to equal 12. But that's the equation of the principal axis. So if we really want to do equation, let's get rid of that. We would say, let's see, that would have to be our hours of daylight each day here, right? So that's going to be, say, f of t equals 12. Okay? Okay, the answer key has y equals 12, but I'm pretty sure they would take f of t would be just fine as well. Okay, C, hence or otherwise, find the equation of this model in the form f of t equals a cosine bt plus d. So now what we're going to do is we are going to go through and we're going to write down the model in that form. So C, we're going to do f of t equals a. That's our amplitude, right? So if you remember from back up here, our amplitude is 4. But now remember, let's see, the cosine normally starts at the top and goes down and comes back up. So since it starts at the bottom and goes up, that means it's negative 4. So I'm going to back up here a little bit to give ourselves some room. So we got f of t equals, and we got negative 4. And we got cosine. B is going to be the period, right? How long it takes to repeat. So it's 12 months. So really on that part there, we're going to have to do 360 divided by 12, which gives us 30. So we're going to put 30 in here. 30t, right? And remember, 30 means that it's going to go through 30 full cycles in 360 degrees, right? Because it repeats every 12 degrees or 12 months. Okay, and then plus d is going to be our principal axis, which in this case is 12. That goes right down the middle. So this would be our equation for C. Okay. All right, and then let's see. Let's go on to D here. For the first year of the model, find the length of time where there are more than 10 hours and 30 minutes of daylight per day. So I'm going to suggest using the graphing calculator for this. Okay, so put the equation here into the y equals -4 cosine 30x plus 12, this exact thing here. And then we want to know when that's going to be, find the length of time when it's going to be more than 10 hours and 30 minutes. So 10 hours and 30 minutes is going to be 10 and a half hours. So we want to do 10.5 as the other one here. And of course, if we hit graph, we are not, 10.5 is going to be just out of reach up here. So here's part of it. Here's part of our graph there. So we want to see a little bit higher up. So we want to change our window. Once this thing stops graphing, and our window will start here. Okay, here we go. We want to see higher up. So our Y max is too low. So we got to change our Y max to, like, say 15 or something like that, just so we can see the 10 and a half. Okay, so we do that and put graph, and then it's going to regraph this thing. Okay, so here's the graph. So we want to know from this point to that point, because all of this in between here is up above 10 hours and 30 minutes. Okay, so we would want to find the intersection. So we'll do second trace, and we're going to do 5 for the intersect. And then we just want to move it closer to this one here so that it finds that one first off. So we'll do enter for first curve, enter again for second curve, enter one more time for the third. And it says the intersection's at 2.26. Let's go 2.266. Okay. So for D, we've got an intersection at 2. I can't remember already. 2.266. Okay, that's one intersection point, right? Up at 10 and a half. And then let's find the other intersection point. So we'll do second trace. And again, we're going to find the intersection again. And now we're just going to want to move this thing over closer to the other intersection point. Otherwise, it's just going to give us the same point over again. So it's slowly moving over. There it is. First curve, yep, enter, goes to the red second curve, enter, guess, yep, enter one more time, and that gives us 9.734 to 9.734. Now, I did go through and look at the answers just to make sure I was getting this all correct here, and you need to make sure you show these points instead of just the answer. Showing these points is actually going to get you one of, let's see, where is it? This one here. These 4 points, at least one of those points is by showing these here. Okay, so what we're going to want to do is do 9.734 minus 2.266, and that's going to tell us how long it's going to take, right? So, second quit, and 9.734 minus 2.266 gives us 7.468. Round that off to 3 significant figures, we get 7.47. Okay, and that's going to be 7.47 months, and you can just leave it like that. Okay. All right, you do not need to convert this months into months and days. You can just leave it as months. Okay. Last part here on this one is E. Calculate the percentage error in the maximum number of daylight hours Boris recorded in the diagram. So thankfully, percentage error is given to us on our formula sheet. So this is what it shows, and we got VA minus VE all over VE, and this is the absolute value of. Okay? All right, and it says right on your formula sheet, VA stands for the approximate, and VE is the exact. So in this case here, our approximate estimation here, like they said that, sorry, the true maximum number of daylight hours was 16 hours and 14 minutes. Our approximated number was 16. So we're going to do 16 minus 16, and then we've got to turn 14 minutes into, this one we're going to have to turn into, let's see, hours, right? I can't remember. Oh, sorry, 16 hours and 14 minutes. Sorry, moving that all over the place, making a mess of this. Let's try that one more time. Sorry. There we go. So we've got to do, so VA is really going to be 16. And we're going to, you know what, let's put this all in a fraction. So we can do this, and we're just going to put it in just like it looks. So 16 minus 16, oh, that's right, the number of months. So we do 16, the minutes. 16 minus 16, and then we've got 0.14. So we got to do plus 0.14 times 60, right? And that's going to give us the total number of hours there, right? And then this is all going to be over 16 point, gosh, let's figure out what that actually is ahead of time, because otherwise I'm just putting weird numbers in there. We don't know. So let's do this. I'm just going to quit and go back, clear that out. So let's take our, keep forgetting what it is, 14 minutes. 14 times, not times. We're going to do 14 divided by 60, and that's going to give us 0.233, so 16.233. As many threes as you can handle putting in there. We'll just give you a little bit more accurate answer, right? So that's 16.2333 hours divided by VE, which is our 16.2333. Again, as many threes as you can handle putting in there, and away we go. So let's try this one more time. Second y equals gives us our fraction. So we're going to do 16 minus 16.2. I'm going to do 6 of them on there. That should be more than enough. Over 16.2, 1, 2, 3, 4, 5, 6. And then enter. And we get negative 0.01437, blah, 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 blah. But remember, this is absolute value, so that means our answer is going to actually be positive 0.01437. 1437. Let me double check, make sure I wrote that down right. 14373. 1437. So that, excuse me, that works just fine. So that's the, so it says to calculate the percentage error. So we want to turn this into a percent. So move the decimal over twice, and we get 1.44% if we round to 3 significant figures. Okay? Okay, that's all we have for the first one. Let's take a look at the second one. All right, number 2. Eddie decides to construct a path across his rectangular grass lawn using pairs of tiles. Each tile is 10 centimeters wide, 20 centimeters long. Following diagram shows the path after Eddie has laid 1 pair and 3 pairs of tiles. This pattern continues until Eddie reaches the other side of his lawn when n pairs of tiles are laid. The path has a width of WN centimeters and a length LN centimeters. Okay, the following diagrams show this pattern for 1 pair of tiles and for 3 pairs of tiles, where the white space around each diagram represents Eddie's lawn. Okay, diagram not to scale. So this is 1, this is 3, it says n equals 1, n equals 3. So the following table shows the values of Wn and Ln for the first three values of n. So let's slide that down so we can see this. And then we can just see the first couple questions there. So one tile, it's the width is 20 and the length is 30. So 20 by 30. Three tiles, the width is 10, 20, 30, 40. And then the height is 10, 20, 30, 40, 50. Okay. So now what they're asking for, what's the value of A? So if it was only 2, how much, what's A and what's B going to be? So basically if we added in another tile here, basically if it looks like this one right here without this one and this one, right? So that means the length would be from here across to there. So that's 10, 20, 30 would be our width. So A is going to be 30, right? And then B is going to equal how tall it is without those two. So that's 10, 20, 30, 40. So that's going to be 40 tall. Okay? Okay, moving on to part B. Write down an expression in terms of n for Wn and L of n. Okay? So what we've got, really kind of a couple different ways you can look at this. You can actually come up with the arithmetic sequence for this if you want. You can use that formula, or you can simply say, well, let's see, we started with 20, this one's 30, this one's 40. It's just what we wrote down here, right? So the width is going to end up being here. We've got with 1. Let's see, so we can say Wn is going to equal, oh my goodness, my dogs. Okay, so we go up by 10 every time we add another layer, right? So, and this is the width, so 10 n, and then we also have to add on, for the width here, we have to add on an extra 10, okay? And the L of n, it also goes up by 10 every time we add another layer, but that one, you got to add, after you start with 10, you got to add another 20 to that to end up with your 30. So these would be our two formulas. Okay. Now again, they do have the formulas in our formula booklet if you would rather, and if we're going to do it that way, or you could do this. You can do Wn equals the first term, which is 20, plus n minus 1 times 10. And then we would just, you could just leave it like that. That would be fine. This is a little bit nicer. So if we were to simplify this, that's going to give us Wn equals 20, and then distribute the 10 to both of those, plus 10n minus 10. And that's what ends up giving us this formula, right? And then Ln is going to be, first term is 30, right? First term, oops, over there is 30, plus n minus 1, and the common difference is 10, which will give us Ln equals 30 plus 10n minus 10, and that there would simplify to this as well. Okay? So a couple different ways to take a look at that. All right, let's look and see what we got going on next. So for C, we have here, show that Eddie needs 144 tiles. Oh, if Eddie's lawn has a length of 740 centimeters. So let's use our formulas here. So we've got L of n equals 10n plus 20, right? So we've got, let's do this over here where we've got some room. So we've got Ln equals 10n plus 20. Now, since we know the length is 740, we're simply just going to plug in 740 for Ln and then solve for n. Right? So we subtract 20 from both sides. And we get 10n equals 740 minus 20 is 720. Divide both sides by 10. And n, the number of two brick layers, is going to be what, 30? Oh, sorry, not 30. Let me Undo that, and that is going to be 72, right? Now, remember, n is the number of 2 brick tiles here. So that's the, if we move this back up here, we can see it. This is n equals 1. So if our n, if we have 72 layers, then what that means is we've got to double that, right? So if n is 72, then we need 72 times 2, which is 144 tiles, right? Which is, it says show that Eddie needs 144 tiles. So starting with this, we went through and did the math and figured out, yes, indeed, we do need to get 144 tiles. That's what show that means. You have to start with your formula, plug in the info that you have, and show that you end up getting 144. Okay. Find the value of Wn for this path. Okay, so this was C part 1, and then C part 2 is going to be find the value Wn for this path, right? So we've got Wn equals 10 times, since we know n is 72, we're going to do 10 times 72 plus 10. So Wn is going to equal 10 times 72 is 720 plus 10. So Wn is going to equal 730 centimeters. Okay? Okay, moving on to D here. Let's see. Find the total area of the tiles in Eddie's path. Okay, give your answer in the form A times 10 to the K, where A is greater than or equal to 1 and less than 10, and K is an integer. So just to kind of remind you here, when you see all this with this simply is trying to tell you scientific notation. That's all that means. Okay, so we're going to give our answer in scientific notation. Okay, so find the total area of the tiles in Eddie's path. Give your answer as this. Okay, so if we know that we need 144 tiles, right? So part D, we need 144 tiles, right? And then each tile is 20 by 10. Each tile is 20 centimeters by 10 centimeters. Okay, so if we multiply that together, that's going to give us a total of 200 square centimeters, right? So if we've got 144 tiles and we know that we know that each tile is 200 square centimeters, to figure out what find the total area, we would take 144 times 200. And that is going to give us our 28,000. Oops, I should not be cheating. Let's actually do this on here. So we got 144 times 200. And that gives us our 28,800. Okay, now it says we got to leave our answer in scientific notation. We can't leave it like this. So the decimal is right here. So to turn it in scientific, we got to go 1, 2, 3, 4 back. And that's going to be 2.88 to 3 significant digits times 10 to the. We took this big number and made it smaller. So to make up for it, we have to make this number bigger. So it's going to be positive 4. So it's 2.88 times 10 to the 4th square centimeters is going to be the total area in Eddie's path. Okay. Okay. Moving on to E. Find the cost of a single pack of 5 tiles. Okay, let's give ourselves a little bit more room here. And there we go. All right, we're running out, but we'll make it. Okay. Find the cost of a single pack of tiles. So now the thing is we have $24.50 per square meter and are sold in packs of 5. So the cost of a single pack of 5 tiles. What we need to do is we've got everything right now in square centimeters, but we need to convert it into square meters. So let's look at it this way. We know that if we have 1 meter by 1 meter. That's the same thing as 100 centimeters times 100 centimeters. And if you forget, our little conversion is King Henry died unexpectedly drinking chocolate milk, right? So here's our units. Okay, so we went from meters over to centimeters, so we move it 2 to the right. So 2 to the right would make it 100 by 100. So 1 square meter is the same thing as 100 times 100, which is 1 with 4 zeros after it, 10,000 square centimeters. So that's our, that's the equivalency there. Okay. So if each tile is 200 square centimeters, so if we take 200 square centimeters and divide it by 10,000 square centimeters, we get 1 out of 50, which is 0.02 square meters per tile. So not a lot. Okay, not very, that's a pretty small area there compared to a cubic meter. Sorry, a square meter. So if we take our 0.02, that's how many square meters we get per tile, and each pack comes in a pack of 5. We get 0.1 square meters per pack, right? So if each square meter cost $24.50, then we would have to, let's see if I can squeeze this in down here. So we take our $24.50 times 0.1, and that tells us that each pack would then have to cost $2.45 per pack. Okay. Okay, and that there is part, what was that? It was part E. So now we got 2 more problems to do and no more room to do it. So I'm going to make some room here. Okay, don't hate me too much. I'm going to just do the rest of the work up here. So find the to allow for breakages, Eddie wants to have at least 8% more tiles than he needs. So find the number of packs of tiles Eddie is going to need to order. Okay, so we know that each tile, 0.02, right, times 144, because that's how many tiles we're going to need, is going to equal, if we multiply that out, we get 2.88 square meters needed. But again, we want an overage of 8%, so we got to take that 2.88 square meters and multiply it by 1.08, because that's going to add the original 100% plus another 8%. And if we do that, 2.88 times 1.08, 2.88 times 1.08, oops, missed an 8 in there. Second insert, give us another 8. And then we push enter, we get 3.1104. 3.1104 square meters of tile. That's what we need. Okay, so then what we got to do is we got to take our 3.1104. Each pack, if you'll remember, is 1 square meter. So we got to take 3.1104 divided by 0.1. Sorry, let's rewrite that so you can actually read that. That's a little better. 3.1104 divided by 0.01 gives us 30, basically just going to move the decimal over 1, 31.104, which means we need to have 32 packs, right? And so let's see, was that what we're asking for? Find the minimum number of packs of tiles Eddie's will need to order. So we need 32 packs, okay? And then the last one is there's a fixed delivery cost of $35. Find the total cost for Eddie's order. Okay, so what we got to do is we know we need 32 packs, right? So we take our 32 and then we're going to multiply it by $2.45 per pack. Plus, we got to add on the $35 fixed delivery cost. So we put that all in. 32 times 2.45 plus 35 gives us 113.4. So it's going to cost $113.40. I like that as an answer, but really officially, if we're rounding it off to three significant figures, $113 is our answer. So I probably should not have circled the original one and then left it like this, $113. I'm not even going to put points here. I'm just going to do 113, just like so. And I'm pretty sure that's what the answer wanted out of us. That's what they're looking for, 113. Okay. All right, that's all for number 2. Let's take a look at number 3. Okay, number 3 says the scores of the 8 highest scoring countries in the 2019 Eurovision Song Contest are shown in the following table. We have all that there. For the data, find the upper quartile and the inner quartile range. So if we're looking for upper quartile, let's do the median first. 1, 2, 3, 4, 5, 6, 7, 8. So there's our median between those two, right? And so the upper quartile is going to be the top part up here because these are the higher numbers. So there's our upper quartile. So that's going to be the average of those two numbers, right? So we'll do A has got to be 472 plus 370 and divide that by 2. So let's move that so we can see. We'll do 472 plus 370 divided by 2 gives us 600 and no, it does not. What did I do for? Oh, yeah. This is a good example of what not to do because this is going to be 472 plus 370 divided by 2. So it's only going to divide the 370 by 2, not both pieces. So let's do this instead. So we'll do alpha y equals, put in our fraction here, and then let's do it this way, the smart way. So let's do 472 plus 370 all over 2, and that will give us the correct answer of 421 is going to be, should label this equals quartile 3. Okay, so that's A part 1, and then A part 2 is going to be the inner quartile range. So we've got quartile 3 here, so we're going to need to find quartile 1 down here, which is going to be the average of these two. So we'd have to do 331 plus 305 divided by 2. So on our calculator, alpha y equals, put in our fraction, 331 plus 305 all over 2. And we get 318 is going to be quartile 1. So that means the inner quartile range is going to be quartile 3 minus quartile 1, right? So we're going to do 421 minus 318. And we can look at that and hopefully realize that that's going to be 103. And that's going to be our inner quartile range. Okay? Probably be a good idea to write this as 103 equals the inner quartile range, like so. Okay, just so we label it, probably would be a good idea. All right, part B, determine if the Netherlands score is an outlier for this data. Justify your answer. So, again, nice part about these questions, they often try to lead you right into the next question, so it's really kind of nice. So if you remember, to test for outliers, let's see, this is part B. I don't know why I put a Q on there. B, outliers. Oh, I'm having a hard time. Oh, outliers is the inner quartile range times 1.5. 1.5 is just one of those numbers you just have to remember to figure out to test for outliers. So We're going to take 103 times 1.5, and that's going to show us what our range is going to need to be above the third quartile and below the first quartile. So 103 times 1.5 gives us 154.5. Okay, so this is again what we have to subtract from the lower quartile and add to the third quartile to see where the outliers are. So we're going to take the lower quartile 1, 318. So we do 318 minus 154.5. And then we're also going to take quartile 3, the upper quartile, 421, and we're going to add 154.5. And that's going to be the boundaries for our outliers. Okay, so if we take 318 minus 154.5, and we get 163.5. So anything that's below 163.5 would be an outlier. So let's see, that is obviously not going to have any kind of outliers there. But of course, if we're looking at the Netherlands, that's the upper end. We didn't even have to bother with that. So sorry, wasted a little bit of time there. So what we really wanted to do is do 421 plus 154.5. And this is 575.5. Anything above 575.5 would be an outlier. 498 is not above 575, so Netherlands is not an outlier. So it asks, determine if Netherlands scores an outlier, justify your answer. So we can't simply just say no. We have to say why. So I would maybe say since 498 is less than 575.5, it is not an outlier. Okay? And maybe instead of saying it, we should probably put the Netherlands is not an outlier, just to be a little bit more clear on that. Okay? Let's see, moving on here to the next part. It says Chester. Let's move it up first and then we'll read it. It says Chester is investigating the relationship between the highest scoring country's Eurovision score and their population size to determine whether the population size can be reasonably used to predict a country's score. Populations of the countries to the nearest million are shown in the table. So here's the same Eurovision score that we had up there, and then now here's the population next to it. Chester finds that for this data, the Pearson's product moment correlation coefficient is R equals 0.249. State whether it would be appropriate for Chester to use the equation of a regression line for y on x to predict a country's Eurovision score. Justify your answer. So basically what they're getting at here is this here. This R value being so low means that we should not use that. It's not a strong correlation at all. So it's really state whether it's appropriate. So we would say no. And I would go with maybe like the R value. Little r value suggests too weak of a correlation. Okay, it's not very high. If it was up above half, then we're getting close. But definitely 0.249 is way too low to use this to predict any kind of Eurovision, any kind of score whatsoever, just because the R value is so low. Okay. Moving on to. I thought there was some more on this. There is more on this. Question 3 continued. Next page. So, Chester then decides to find Spearman's rank correlation coefficient for this data and creates a table of ranks. So here's the Eurovision score rank, 1, 2, 3, 4, 5, 6, 7, 8, and then here's the population rank with a couple missing pieces, A, B, and C. So it says write down the value of A, B, and C. So what we have to do is we have to refer back to the other table here. So I'm going to bring that back up here at the same time. Okay, so here's our population piece. So we have to rank these. So Russia is going to be the highest. That's 1. Italy is 2nd. And then the Netherlands is the next highest with 3rd. These two tie for 4th and 5th. 4th and 5th, and then therefore this one's going to be 6th, 7th, and 8th. Okay, so we know that A has to be 6. Okay, now B and C are these two, and those are the two that tied for 4th and 5th. So what we have to do to come up with that rank, right, that value, is you're going to have to do 4 plus 5 because they tied for 4th and 5th. So 4 plus 5 divided by 2 gives us 4.5. So each of these are going to be 4.5. So if they're tied, you got to split the score between the two. Okay. Find the value of Spearman's rank correlation coefficient R. Okay. So let's see what we're going to want to do with that. There is we're going to want to here. Let's write these in here. So this is 6. This is 4.5. And this is 4.5. We're going to want to get our graphing calculator back up here. And we're going to go into Stat. And we're going to Edit. And then we're going to put these here all in order. So we'll clear those out. Clear these out. Come on. There we go. And then we'll put these in just like they look. So 3, enter, 2, 1, 6, 4.5, 7, 8, and 4.5. Right? And that is the first 8 because the next one would be 9. And then this one simply is 1 through 8, right? Always a good idea to, after you enter everything in, to just kind of double check to make sure. Ooh, look, I put 45 instead of 4.5. So let's go back up and fix that, because that would definitely throw our data off. And the grader here is not going to be able to see that you just that I inadvertently put a 45 instead of 4.5. So good thing we double checked. Okay, so then now it says to find the value of Spearman's rank correlation coefficient. So we go back into Stat, and we're going to calculate a linear regression. How well does this fit a nice straight line, right? So we do that. Come on. Here we go. Enter. All of our X is in list 1. All of our Y's are in list 2. There is no frequency list, so we leave that blank. I'm not sure what that is. Store regression equation. Anyway, go down to calculate, and it gives us that. There's our R value, 0.6826. So we're going to go 0.683. So find the value of Spearman's rank correlation coefficient. So we've got this one. Let's do E part I. And I've already forgotten, 0.683. 0.683 is going to be that one. And then EII says interpret the value obtained for R of S. Okay, so there is definitely a stronger positive association between the population size and the score. And when we're interpreting this, you really got to make sure that you include what each of the X and the Y's are. You don't want to just say, oh yeah, it's strong because the R value is higher, or it's stronger. You got to say what's strong. Okay, so again, we'd want to say stronger positive association between population size and score. Okay, so I wrote it down there, and again, you will not get full points unless you put population size or a rank and the score. Okay, so make sure that you put those in there. All right, And then part F here, we will, when calculating the ranks, Chester incorrectly read that the Netherlands score as 478. Explain why the value of Spearman's rank correlation R does not change despite this error. Okay, so I just brought this over onto the page here so we can see it. So this one incorrectly read the Netherlands score as 478. So if this changed to 478, guess what? It's still the highest score. It still has a ranking of 1, which is what it had before. So even though it was off by 20, it doesn't change because it's still the highest score there. Okay, so we again need to make sure that we describe this well so that the graders can understand that we understand what's going on. So the miscalculation does not change the rank score. Gotta have the word rank in there somewhere. Otherwise, you will not get your full points for this. Okay? So something like this does not change the rank score. Again, without the word rank in there, you will not get full points. Okay. Let's move on to the next problem. All right, number 4, a sector of a circle, center O, and radius 4.5 is shown in the following diagram. Find the angle AOB. So AOB. So we're looking for this whole angle here. What I'm going to do to figure out this angle here is I'm just going to just use part of this triangle. This, and this here. This is going to be a right angle. I'm going to figure out this angle right here, 4.5 and 4. And once I've figured out what this angle is, I know I just have to double it to come up with the entire angle, right? So from this angle, opposite, adjacent, hypotenuse. So this is hypotenuse. This is adjacent. Our dear friend SOHCAHTOA, which is not going to be on your formula sheet, so you're going to want to remember that. So we have hypotenuse and adjacent, which is cosine. So we would want to do for A, part I, we're going to want to do cosine of theta is going to equal A, which is 4, over H, which is 4.5. Okay, so if you'll remember, whenever we're trying to calculate an angle, let's see, we're going to want it, we need to do cosine, we need to do the inverse of cosine, cosine of the negative first. So we're going to do second cosine, get the little cosine of the negative first, and then we will do, I'm going to do alpha y equals, just so we can get our fraction in there. You can also just do 4 divided by 4.5, and that would work as well. 4 over 4.5. And we push enter, and that will give us an angle of 27.266. Theta equals 27.266. 0.4. I'm going to go with these 5 digits. I'm going to write this down here, but then for our answer, once I take this and double it, because we have to double it, remember, because we only came up with half of this. We want the whole thing. So we simply take that and then multiply by 2. Super important to not round it and then double it. You want to leave your original answer in there, double it. We want to do as little rounding as possible until we're ready to give our final answer. And then when we go back and continue to use these numbers here in future problems, we don't want to use the rounded answer. We want to use our the answer that is the most accurate. So anyway, we end up getting this angle AOB with this funny little angle sign in there is going to equal 54.3 degrees. Right? Did I write that down wrong? Right? 54.5 degrees. I did not. Okay. 54.5 degrees is what angle AOB is going to be. All right? Part 2 says find the area of the shaded region. So now we're going to figure out what that is. So to figure out that, I'm going to say we need to take the whole piece of pizza, kind of looks like a pizza, subtract just the triangle part, and then we will be left with just the crust, the shaded area right there, right? So that's what we need to do. We need to figure out the area of this whole thing, subtract the area of just the triangle there, and it's going to leave us with this section up there. Okay, so what we need to do is use the area of a sector formula, which is the angle, which we just figured out is 54.5, but I'm going to really write it as 54.5321 over 360 times, and it's the area of a sector, so it's going to be pi r squared, right? So instead of doing the r squared, writing the r squared in there, I'm going to actually put the r in there, which is 4.5. Pi times 4.5 squared. That's going to be this section here. And then we're going to subtract off this triangle right here. So that's just going to be 1/2 of the base, which is this, times the height. We don't know the base right now, but we do know that the height right there is 4. So we're going to multiply that by 4. So what we got to do is we got to figure out what this piece is right here. So good news is this whole base here is just this length times 2, right? So I'm going to do a squared plus b squared equals c squared. We could also use trig functions to figure that out. But I'm just going to do a squared b squared equals c squared, which should be just fine. Right? So in this case here, as long as we use the 4.5 for our c squared, a and b can be, we know that one of those has got to be 4, and then the other one is going to be, we'll call that b for base. Right? So we get 16 plus b squared equals whatever 4.5 squared is. And that gives us 20.25, right? So, and again, I would be doing that. I just don't have a lot of room here. I'd be doing this all on my paper, all kind of do this all work down linearly so that it's really easy for the grader to figure out what's going on. But let's just move this back over here and we'll just make room later. So we got 16 plus b squared equals 20.25. Subtract 16 from both sides, and we get b squared equals 4.25. So we got to square root both sides to get the b. So minus 16 from the 20.25, and then we got to square root our answer, right? And we get 2.06155. 2.06155 is going to be this base right here. But again, remember, we want the whole thing, so we have to double that. So times 2, which is 4.1231. So 4.23, I think I messed that up already. 4.1231. 0.1231 times 4. Okay, so this right here is going to end up giving us the area of this sector here, right? So we'll want to put that into our calculator, and then away we go. All right, I'm going to pause this so just so you don't have to watch me put this all on the calculator. It'll be kind of boring. Okay, so this, I believe, is everything put in correctly. I just put -1/2 as -0.5, but everything else should look exactly the same. Push enter, and this should give us our beloved answer, which is 1.39042. 1.39042, right? If we want to if we round it off to that spot right there. So officially our answer is going to be 1.39, right? And this is meters, so that's area. So it's going to be 1.39 square meters is going to be the area of that shaded segment, okay? Now, just like at some point when you're going through and looking at this, you really should look at the answer key, and you'll notice you're getting a fair amount of your points is actually you showing some of these steps in here. So it never hurts to get in there and show your steps. Remember, if you think you did something wrong, just put a line through it, but don't erase it. Don't scribble it all out. Make sure that it's still readable, just in case you did actually do it right. Okay, so again, that's the end of part A. So moving on to B, it says a square field with side 8 meters has a goat tied to a post in the center by a rope such that the goat can reach all parts of the field up to 4.5 meters from the post, which is a little confusing, but basically you can see that there's the 4.5 right there. They're just saying that the goat can really only reach up to there. Okay, now let's read down here a little farther. Is that it? That's all we need. Let's give ourselves a little bit of room to work. So find the area of a circle with radius 4.5. So they're saying we're going to take this and we're going to use this to draw ourselves a circle with a radius of 4.5. This is not perfect, but you kind of get the idea. That's roughly what it looks like. You don't get all these corners in there, but you also get this extra piece out here. So if we're going to do B part I, area of a circle is going to be pi r squared, right? So area is going to equal pi times the radius of this thing is 4.5 squared. So our area is going to be pi times 4.5 squared. Gives us that the area of the circle is 63.61725. 61725. Okay, I'm going to go to that, but truly the area that we want for our answer is going to be 63.6, and this is all in meters, so meters squared. That's going to be the area of our circle, right? Okay, and then BII says find the area of the field that can be reached by the goat. Okay, so that's basically all this field here, except that's outside the fence, that's outside the fence, that's outside the fence, and that's outside the fence, right? So we got to take those 4 sections off. Guess what? That's exactly what these are right here. This 1.39, that is, look, that's this section right here, because look, 4.5, and that's 4, and that's the little section. All these sections here are that 1.39. So what we're going to want to do is take our 63.6, but again, I'm going to start with 63.61725, and then we're going to subtract off 4 of these things here. And again, I left the unrounded number, or not as rounded number, back up there. 4 times 1.39042, and then let's see what we get. So we've got that number in there already. Let's just leave that. And then we're going to subtract 4 times 1.39042. Subtract those off and we get 58.0555. 58.0556 really, if we round it off, right? So area of the field that can be reached by the goat would be 58.1, right? Because this 5 is going to round that thing up. Okay, and we get 58.1, and that's going to be square meters. Okay, now just something really quick to note. I'm going to just show you what would happen if we did our math with our rounded numbers instead of the non-rounded numbers. Okay, I'll just show you really quick. Here it is. We did 63.6 minus 1.39 times 4, so our answers that were rounded, multiply that by 4, you get 58.04, which would round to 58.0 instead of 58.1. No, it doesn't seem like a big deal. It's really not a big deal, but it could end up making it so that you would lose a point because your answer would actually be off by a little bit. Okay, so whenever you're calculating stuff, use non-rounded numbers and only round at the very end. Okay, and then if you're using those numbers again, use the non-rounded numbers so you get a little bit more accurate of an answer. Okay, and then part C. Let V be the volume of grass eaten by the goat in cubic meters, and T be the length of time in hours that the goat has been on the field. The goat eats the grass at the rate of dv over dt equals 0.3 t e to the negative t. Okay, so remember d is like our change in volume over versus change in time is this equation here. So find the value of t at which the goat is eating the grass at the greatest rate. Now, just in looking at this, it's a little confusing. The big thing that is kind of a key in here is the greatest rate. So what's going to happen is if we graph this thing, it's going to have some kind of like curves on there. Greatest rate, we're going to look for some kind of maximum in here. So let's put this into the calculator, this equation, and just see what it looks like first off and see if we can make it make some sense. So let's get rid of these other ones here. All right, and then we're going to put this in here. So we're just going to simply put in 0.3, and then these t's are going to be our x's, right? 0.3 x, and then we're going to do second e to the x. That's an e, that's not a variable. E is an actual number, right? To the negative x. Okay, so now we graph that, and let's see what shows up. Okay, here's what is showing up. It's this thing here. Now, if I'm betting on this, and it says that, you know, what's the greatest rate that they're eating at? Here's what I'm betting. If we zoom in on this graph here, it's going to look like this. It's going to go up like this, and it's going to kind of max out right there, and then it's going to come back down. We're looking for a maximum point up here somewhere. So let's see if that will work. So we do second trace. We're going to look for a maximum, which is number 4. And we want to start over here to the left where we know for sure we're below it. And now what we're going to do is we're just going to move to the right, and we're going to watch that y value, and we're going to watch it go up and up and up. It's now into 0. It's into the positives. It's going to keep going up. And then now what we're going to do is we're going to keep watching it. And as soon as it goes back down, we know we've hit a maximum. So 10.9, 11, back down to 10. So we know, look at this thing, it's coming back down. So we know somewhere in here there's a maximum. So if I do enter here, and it says give a guess, it's going to find the highest y value in there, and it's going to give us that y equals 0.1103. So we get y equals 0.1103, right? So which really means we end up getting 0.110 for that there, the y. But really what it was asking is find the value of t, right? So the t value is time here, and that's at 1. So we get t equals 1, and then that's what the maximum value is. So it says find the value of t at which the goat is eating grass at the greatest rate. It's when t equals 1. Okay? Now you're actually going to get a point, another point of calculation point here for showing this 0.1103 number, or by showing a sketch. So we actually, we put a little sketch on there. But what you'd want to do with this one here is you'd want to show that this 0.1103 is our dv over dt. Okay? So this is, I'm not going to circle that because that's not our final answer, but that's how we got our answer. So you can get the work points by doing that, or by just throwing a quick sketch of the graph on there, which, let's see, I can't quite remember. There we go. Okay, so it looks like this, right? And then I'm going to kind of over-exaggerate it, and there's my point, and I might even, if I've got time, which of course I got time, 0.1103, I'd write the coordinate down there. That's going to get us our work points as well. Okay? All right, last one, number 5. The aircraft for a particular flight has 72 seats. Airlines records show that historically for this flight, only 90% of the people who purchase a ticket arrive to board the flight. They assume this trend will continue and decide to sell extra tickets and hope that no more than 72 passengers will arrive. The number of passengers that arrive to board this flight is assumed to follow a binomial distribution. That's a big hint for us, with a probability of 0.9. Okay, 72 seats, only 90% of the people purchase a ticket, and they hope that no more than 72 passengers will arrive. The airline sells 74 tickets for this flight, and find the probability that more than 72 passengers arrive to board this flight. So that means it's going to have to be 73 or 74. What's the probability of that number showing up, right? So here's what we want to do. We want to get into our calculator here. And let's move it over here so we can see. And we're going to, let's clear everything else out of there. And what we're going to want to do is we want to get into our binomial distribution, DISTR, distribution. So we do second vars. And the normal, here's our normal distribution, but it tells us right in here we want to do the binomial distribution. So we got to go down here until we find it. And then there we are. So it's binomial PDF or CDF. CDF is going to give us a big group of numbers. PDF is going to give us an exact number. So we could go through and figure out what 73 or 74 is, and add those together. Or I'm going to actually do the binomial CDF here, and we're going to find everything up through 72. That'll be, I think, a little bit less work. So number of trials. We're going to have, we sell 74 tickets. Okay, so our trials are going to be 74. Probability of success is 0.9, which it tells us there, 90%, and also 0.9. And then the X value, what we're going to do is it says find the probability that more than 72 passengers arrive to board the flight. So what we're actually going to do is find the exact opposite. We're going to find the probability of anywhere from 0 to 72. So our X value is going to be 72, right? And then we're going to paste, and we're going to get this here. And you're like, what happened? You got to push enter one more time, and then it actually calculates. It'd be 99.6% chance that 0 through 72 passengers will arrive. But we want to find the opposite of that. Find the probability that more than 72, so not the opposite, but really the, what do we call that again? The complement of that, right? So what we want to do is we want to do 1 minus this answer, and this is going to be our probability, 0.00379. I feel like I'm off by a little bit. What am I off by here? Let me check something. I'm good. It's fine. So now we did a bunch of this on the calculator. It is going to be a really good idea to write this stuff down over here so that in case we mess something up, then we can possibly get some points. And then also it shows that we know what we're doing. We're not just throwing down some random number. So I'm going to actually write this out. So I'm going to do binom CDF. I'm going to put 74, 0.9, 72, right? And that gives us, ended up giving us 0.99621, 0.99621. So then we did 1 minus 0.996, Did I get those numbers right? 0.99621 if we round it, right? Which ended up giving us 0.00379. And I might even give a 379124, just in case we might need to use this later. So it does say find the probability that more than 72 passengers arrive to board the flight. We don't want to leave it as a percentage. We want probability. We want to leave as a decimal, rounded to 3 significant figures, right? 0.003 is the first, 7 is the second, 9 is the third. So that would be the probability of, let's see, more than 72 tickets. Okay. Let's just circle that part for our number and get rid of the rest of this. Okay, that's icky. I can erase it. Okay. So we get 0.00379 as our probability that more than 72 passengers will arrive to board the flight, which is less than, it's like 0.379%, so way less than 1%. B part 1, or B part I, says write down the expected number of passengers who will arrive to board the flight if 72 tickets are sold. So expected number, so they expect that 90% of the people are going to show up, so we're simply just going to take 72 times 0.9, and that will give us 0.9 times 72 is 64.8. 64.8 people we would expect to show up. Okay? Now, BII asks us, find the maximum number of tickets that could be sold if the expected number of passengers who arrived aboard the flight must be less than or equal to 72. Okay, so now that's a little different. So we want to have 72, not 77, 72. I can fix that. There we go. And we want our number of passengers to be less than, let's see, write down, oh, there we are, number of tickets, so less than or equal to 72. So 72 is going to be on the greater than or equal to side of our formula, and we know that 90% of, say, X, the number of passengers who are going to arrive. So we can put that as X or N or whatever. So then we would simply just divide both sides by 0.9, because we're saying 90% of what number is going to give us at absolute most 72, right? So then we take our 72 divide by 0.9, and that gives us 80. So X is going to have to be less than or equal to 80. Okay. So that would be this part here. Maximum number of tickets, 80 or less. And then our last part here, C, says that each passenger pays $150 for a ticket. If too many passengers arrive, then the airline will give $300 in compensation to each passenger that cannot board. Find to the nearest integer the expected increase or decrease in money made by the airline if they decide to sell 74 tickets rather than 72. Okay, so now here's where we're going to do some calculations. Okay, so we can make a little table here. So we've got tickets less than or equal to 72. So this is going to be the probability of all these, like 0 up to 72. And then we also got to figure out, because like if 72 or less show up, no money will be having to be given back. If 73 show up, we're going to have to give back $300. That's we being like, we are not this airline, but you get the idea, right? And we also got to figure out if T happens to equal 74, because then we're going to have to give 300 times 2, $600 back, right? So good news is we've done some of these calculations already. The probability that T is less than or equal to 72 is this one right here, right? That's this one here. 74 trials, 90%. What's the probability it's going to be 72 or less? Is going to be 0.99. That's a 0.99621, right? And then probability that it's going to be 73, we're going to have to go through and we're going to have to figure that out. And same thing with probability of it being 74, but at least we already know this one. Okay. So, now if it ends up being these 72, we're going to end up not having to pay back any money at all. So I'm going to like pump the brakes here a little bit, and let's figure out if we get 72 or less, then that's going to be 72 tickets at $150 each, right? So if we do 72 times 150, that's going to give us how much the airline's going to take in for that flight, right? So 72 times 150 gives us $10,080. $10,800, right? So that's if we end up in this range here. Okay, now 73, if we end up getting say 73 tickets at 150, we can do that. But the problem is, if we get 73 people showing up, then we have to end up taking off. Oh wait, well, this is actually if we sell 74. So let me back up here a little bit. So this is if we sell 74 tickets, but we end up getting 70. We end up having 73 people show up. We're gonna get our 150. Where's that extra zero coming from? Let's get rid of that. Oh, that was an extra $sign. Let's just write it so we can actually read it. How about that? So 150, right? And then we're going to multiply. So if we do 73 tickets, at 150, we actually are going to sell 74 on all of these, right? So if we end up 73, not 73 tickets, but 73 passengers show up, what's going to happen? I'm going to back this up here a bit. Let's erase that and then try this again. Okay, so this here is if we just end up selling 72 tickets at 150 each, guaranteeing that everyone's going to get on, that's how much we're going to make. Okay. Now, what we want to do is we're saying, hey, instead, let's risk it. We're going to sell 74 tickets. Okay. So if we sell 74 tickets and 72 or less people show up, we're going to end up making a little bit extra money, right? Because that's going to be 74 times 150, which is going to end up giving us, so if we do 74 times 150, that gives us 11,100, right? Okay. Now, that's if 72 or less show up, because we're selling 74 no matter what, right? So if 73 show up, we're going to have to do 74 times 150, which we already know is 11,100, but we're going to have to give back $300 on that. So that's going to end up being 10,800. Okay. And then we also are going to need to take a look at what would happen if we got 74 people. So if we did 74 times 150, that's again still our 11,100, but then we'd have to give back $600. That's going to be 10,500. Okay, so that these, again, I probably shouldn't circle these because these are not our final answers. But that's how much we're going to make off of each one, right? So 72 or less show up, 99.6% chance that's going to happen. We're going to make 11,100. Okay, so let's do this. 11,100 if this happens. Make ourselves a little chart here so this is a little bit more clear. If we get 73, this is the one if we get 73 tickets. This is 74 tickets, and this is if 72 or less show up, right? So 73, we're going to come back with 10,800, and then 74, we're going to end up with 10,500, and we just want to figure out what the probability of each of these are. So what we're going to want to do is go back into second distribution, and then binomial. And if we want to figure out exactly 73 and exactly 74, we want to do binomial PDF. C is a combination. PDF would just be one of those. I'm going to push enter. Our trials is still going to be 74. Our P value is still going to be 0.9, 90%. And then our X value in this case is going to, instead of 72, it's going to be 73. And this is going to give us the probability of exactly 73 happening, which is not be very high, and it's not 0.00338. So we get 0.00338, if I remember right. 03380, good. And then we're going to go back and do the same thing except for with the 74 there. So a little bit of a shortcut is we can highlight that, push enter, and then change that 73 to a 74 and push enter, and that gives us 4.11098. 4.11098, but it's times 10 to the negative fourth, so that means 1, 2, 3, 4. 0.000411. 0.00041, maybe another 1 to 9, rounds that 0 to a 1 there. Right? Let's double check. 4.11, yeah. Yep, got that. Okay. So now I know what you're thinking. It's like, this is a lot of work. It's also worth a lot of points. So possibly worth the work that we're putting into it. So all we need to do now is just multiply these together and add them all up to see what our total expected increase or decrease would have to be. Okay, and that increase or decrease is going to be, if we just sold 72, we're going to take in 10,800. So we're going to see if we could end up possibly making a little bit more than that, right? So what we're going to have here, again, ran out of room, so let's just scoot it down here a little bit. Use this here. So I'm going to take 0.99621 times, that's the probability, times 11,100. And then we're going to add to it the probability of exactly 73 happening, which is 0.003380 times how much we'd make, 10,800, plus probability of exactly 74 people showing up, 0.0004111 times 10,500. Okay, so we're literally just going to put this whole thing into our calculator, because we wrote it all down, which is going to be good for us for getting some, showing our work. And in case we did something wrong, the grader will be able to take a look at that and see what we did. Oops, second quit. I wanted to do clear, just kind of like to have a clean screen to start off with. So 0.99621 times 11,100. Right, and double check your, let's just put it all in and then we'll double check, plus 0.003380, don't have to put the extra 8 on, the 0 on there, times 10,800, right, plus 0.1234, not 4 but 3 zeros, and then a 4111. So let's just double check to make sure we got these all in there, right? We got 3 zeros and a 4111. Oops, times 10500. Right? Oops, and I push enter, except for I forgot to check the rest of them. 0.99621, 0.99621 times 11,100, 0.00338 times 10,800, and then we already checked the last one, so we should get this. We get 11,09875. 11,098.75. So it says to the nearest integer, so we get 11,099 would be our expected value for this, for if we sold 74 tickets rather than 72, this is our expected income. So what we're really looking for, again, I keep circling stuff when we shouldn't be, maybe underline it. What we now need to figure out is what's the difference between 10,800 and 11,099. So we simply take 11,099 minus 10,800, and that's going to give us $299. So it says find the expected increase or decrease. We only wrote $299, so we're going to want to put $299 increase. Okay, money made by the airline if they decide to sell 74 rather than 72. Okay. Okay, you could also have written $299 gain. That's what the answer key has, but I'm pretty sure $299 increase would work as well. Okay? All right, that's all we have for paper 2 problems. If you have any further questions on any of these, please feel free to ask me in class. Thanks.